sir? What if sir hear me, sir?
Yeah, mommy, I hear you. We're going.
Swimming.
Leave my car.
You leave the car? Hello?
Writing. Whatever they did in Harry Potter. Scuba diving.
Hello?
Baking. Playing musical instruments.
Good evening, viewers. Good afternoon. Good evening, everyone. I would normally come in at 7:15, but I heard somebody calling me just now, so that's why I'm in now. Who was calling? Somebody was saying that they're in the car. All right. Orion.
I literally have no word. No coordination. Yes.
All right, so good afternoon, students. Well, evening. Good evening, students. How wanna do?
Evening, sir. Well, so far.
Good, thanks. Good. What about the others?
Doing good so far, sir.
Nice, nice, nice. I'm still taking suggestions. I hear some students, about 3 students, saying that they got 1 for the answer. I disagree with them, but I don't know what they're talking about. What about the rest of you?
One is the conclusion, sir.
Say that again.
One.
One.
Yeah,
I
one.
don't know if you all are correct enough. I really don't know. What about the others?
Yes, sir, is correct. Is one.
You get 1? I
Yes,
don't
sir.
know. I disagree. Is there anybody else that got a different answer?
Still working, sir.
It's still working? All right, hurry up and work, because Azra and the whole of them wrong. Cherise, Courage wrong. Tariq wrong. Tony wrong.
Make we see
Yandra wrong. Erlington wrong. We want to see who get the right answer.
Since it's the everybody wrong, what answer you get, sir?
Tajay, don't look at me. You're wrong too. All of you are wrong. Answer is not
Okay, sir.
1. Mm. I need 2 more people to answer me. Then, 1/1. Tariq, what's the difference? 1/1 is how much? 2? I love it. All right. Very good, students. Excellent. 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 Your answer is indeed 1. Very nice.
Alright, sir. Can I go?
Let me know if you are okay. Talk to me now. I can move.
So I just go up a little. What's that? And it's
Talk to me, guys. Talk to me.
Yes, sir. Copy that.
Nice. And that your answer is indeed. All right. So very good. I am proud of you all. Of course, the ones who made an effort to get the stuff done up. Very nice. Is there anyone in the class who had a difficulty working this question? Speak up. Talk to me.
Sir, the only difficulty was that I just have saw it. So as I began speaking, I just started to work on it.
Okay.
Well, for me, my problem is that I keep forgetting that it's a two-stage issue, two-stage problem. If it's a case
Oh, so
where,
you never showed the indeterminate form.
yeah, so I keep forgetting to, I keep forgetting, like, say, if it's a case where the solution gives the answer to be about 0, 0, after that I have to choose one of the methods to gain the actual answer. That's what I keep forgetting to do.
Okay.
And then I realized, like, say, and then I realized once I got like 0, 0, I realized that I had to use the trinomial to get the actual solution.
Mm-hmm.
Sir,
Yes, love.
sir, my difficulty is after I get the x4, x plus 4, x plus 3, I stopped. I didn't go any further.
My difficulty too, sir, because I know how to factorize the middle number for it to add and 7 for it to multiply and get the 12. I know that, and then after that I'm just blank.
Okay, but on out of order, when you can't do my question and just leave it halfway. Let me ask you a question, Lottie. You ever eat a nice plate of oxtail and beans and gungo rice and peas and sorrel and vegetable and mac and cheese and potato salad and all of the niceties and eat it halfway? Talk truth.
You know, it's a good done.
I love it. All right, never mind. So so it is going to give you, so you need to practice a little bit more. You have to practice and practice and practice. Wherever you stop, just make sure that you know you can continue doing as you go along. So
Sir, I'm trying because I'm evil watching the videos. I think it's gonna take a little more time because you know I was out of the system and you know these things take practice and practice and practice. So if I watch a video and go over, I might probably can do it, and then after probably if I try it tomorrow, then I am back at square one. So it's gonna take a little while and probably some extra help.
Nice, no problem. No, sir, that's fine, and that's why we're
Do
here.
you offer extra help, sir?
Have a wonderful rest of the night. You don't need no extra help. You come to class and you open your eyes and your ears. Matter of fact, you reach home this time.
I'm at the office. I don't know.
Oh.
I can't reach home. I'm at the office. So by the time I leave here now, then I have to journey home.
No, man, I want you. Me and you talk, man. I want you. I mean, talk about you leaving office so late. I want you to be very comfortable, and I don't know if the office space is the best place for work. But never mind. No, man. Guess what? To be honest with you, you're not gonna need no extra help. If you just do what it is that you need to do, you will be fine. However, and
but
I'm
sir,
saying
I do someone any focal the first so and all I finish is five questions out of the 15. If I do some whole per reading, can I see some signs and some like something?
Yeah, man, and that's not a problem. Do me a favor, guys. Not just Lottie, but for the rest of you. I want you to assess yourself as you're going along. And if you find that you are struggling, you know, wanting to sit down and walla walla in on the struggles, say something. I am expecting and I want all of you, all 20 plus of you to pass the course. I don't want anybody to fail. I don't want anybody to fail. I've taught calculus courses before, calculus 1 and calculus 2, where everybody in the class passed. Everybody in the class passed. They don't all get A's, but everybody in the class passed. I don't like doing a teaching 10 students and 9 pass and 1 fail. But the one who fail could do the same thing like the other 9. So if you have an issue, I want you to talk to me. Reach out, get my attention in the group first, and then you reach out. So you know we can put some things in place.
Sir, good evening. Oh, you set it up on the calculator? Because you persons were talking about using the calculator. How do I find that function on the calculator? If it is a function.
This sound like Nikki, a fair background that. Yes. Yeah, what you saying now for my class?
Sir, I don't want to miss it, so I try to.
Oh, bless the Lord. I'm gonna buy a bag of tickers. Thank you for coming. All right, how is it? No, you can't calculate the limit on a calculator.
Oh.
You're not able to calculate the limit on a calculator. Not at all. But it's just, as I said before, I don't want you to worry about it. All right, let me move it to something else, and then if needs be, we can come back and look at this. I don't want anxiety to take us where it is that I'm not able to move forward, but I will move, and then just like what I'll do, we'll give you a little one question to see how far you are, and then we'll come back. So I want all ears, and Nikki, I respect that. I think you recognize that, boy, you missed this. It's going to be a little difficult for you to catch on. All right, now I want you to work with me. Indeterminate form, including positive infinity. Rockstone. Then, sir, you gave us an indeterminate form. It's 0 over 0. So you can have indeterminate when it is infinity over infinity. Yeah. So it is very important. Very important. All right. I want to dissect this a little. Let me bigify this because I want you all to see what is happening. So it says the limit as x tends to infinity. That's not an 8 that is sleeping on its side. That's a sign for infinity. That's a sign for infinity. So the limit as x tends to infinity of x to the 4th minus x squared over plus 7 over 2x to the 4th minus 6x cubed plus 2. No, I want you. I want some creativity in mathematics.
Hold on, sir. Sir, question. Are you going to work out the previous question that is posted?
The one that I gave you as a warm-up?
No, I just came in. So the 2 questions that was given before, are you going to, like question 6 and 5, are you going to work those out?
Question 6? No, man, question 6 was already worked, you know.
Scroll up. Let me take a screenshot.
Snap that.
Hold on, let me just take a picture of it. All right, so the one below is the answer for question 6.
Continuation. So snap that one now.
So
snap it.
Hold on. Yeah, snap it.
Other one.
Yeah, I got that.
All right, good. So you can go through that and then we can talk afterwards if you don't following what is happening there. It's just a review of what we did last class.
Okay.
So this, what I'm doing now is is what we're doing now, just starting off with. All right, so I want you to look at this question. X to the fourth minus x squared plus 7. Number one, creativity, you know. One, creativity. Creativity. That's what I want. Creativity. Did I say creativity?
Yes, sir, for the sixth
Okay,
time.
all right. Yeah, creativity. For those who didn't hear, creativity. All right. Now, my first term in here says x to the fourth. Let me, this is x to the fourth. X to the fourth. When I raise my x value to the fourth power, it's nothing becomes talk truth.
When you raise your x to
Repeat
the
what
fourth,
you just said, sir.
I'm saying if I have a value of x,
yes,
and I raise it to the fourth power, do you think it's a bigger value I'll get?
when you raise x to the fourth value, but it's infinity, so it could be any
Hold
value.
on. Hear what I'm asking. If you raise x, if you raise a value, any value of x to the fourth power, do you think it's going to be a bigger value?
You're going to get a bigger value, sir.
Not bigger, don't.
Yes.
Except
except
whole
if it's
leap.
zero.
Whole leap more. Very good.
What, sir, what about zero then? Cause that could be any.
No, hello.
No, we
Zero?
need zero.
If you raise zero to something, no zero you have. So you have a non-starter. And remember, no, we are going to infinity. So if it is that I'm using 10 for argument's sake. When I raise 10 to the fourth power, how much I get?
10 to the fourth power, I think is for 10 to the fourth power.
Leap.
I think it's about 10
10
10
times 10.
10,000.
10 times 10 times 10 times 10 times
Should be 100,000.
100,000.
10,000.
No, 100.
10,000.
10,000, sir.
10,000.
Yeah.
Isn't 10,000.
10,000. So imagine you have $10 and you invest it and you get in raised to the fourth and you draw down $10,000. Enough money that you know. And if you want to make it sound even nicer, say $10 US and then you pull down 10,000 US dollar. Low.
Rich.
Me if I told you, me know it's enough bag and boot for you that you know. Will it for something?
I told you.
So I want you to get what I'm saying. So this number is going to be big. Now work with me now. So if I use the same value as I use for this x to the fourth and raise it to the second power, which value do you think bigger?
X to the fourth.
X to the fourth power will always be bigger.
Right. So if I take out, so even if I take away the x squared from the x to the fourth, we still have a big value, don't?
Yeah.
Good. I'm gonna add plus 7. That means I have a big value up here, don't?
Bigger value.
Because when you have two terms that are equal, you subtract the powers.
No. Hold on. Careful right here, so.
Sir, can you please say that again in a simpler term?
All right. Say what in a simpler term?
You're talking when you raise one x to the fourth power to a different value. Can you repeat what you are saying?
Ready. Radam. I don't even know about Radam. All right, let's go. X to the fourth. What I want to do some imagination. X to the fourth in the numerator is going to be a bigger value than x squared and 7. X to the fourth is a bigger value than x squared and 7. So I'm saying to you, I want your imagination here. What I want you to look at for me is that x to the fourth the value that I would get when I evaluate x to the fourth, and I subtract it from x squared, and then I add 7 to that, I will still have a big value. So that big value I'm going to call infinity. Just use the imagination. But I cannot. You see me? Just work with me. This 2x to the fourth now is going to be even a bigger value than the first one up here. So because this is 2 times the bigger value. So for example, if it is 10, the first one again get 10,000. This one again be 20,000 because it's even bigger. All right. Minus 6 times x to the third power. No, x to the third power. It's still a big value, you know. Times it by 6, but it's not big like the one here. Talk truth.
Yes, sir.
Yeah.
X to the third power is
So go again with that.
1,000.
So this two is on it. 2x to the fourth power. Because
Yeah,
I know
man,
the
so-
one just hold the sum up there. So.
Yeah, man. The 2x to the fourth power is what we're talking about, you know.
Okay, sir. Okay.
Yeah,
Because I
man.
thought
So
you
the
just to I see blue. I thought you just.
The 2x to the fourth. No, there's a reason I
Okay.
put the blue there. I soon come out. I'm going to tell that story a little later.
Okay, sir.
That one is an Anansi story, so I have to go wait.
All
right, so- Yeah. When I finish, you're going to say, oh, let me see what story they're talking about. All right. So I'm saying this 2x to the fourth. When I evaluate 2x to the fourth, whatever x is, when I evaluate this is going to be a bigger value when compared to this one. And when I add 2 to it, I still get a big value. So I'm going to say it's infinity over infinity.
4.
All right. So remember, I just used 10 a while ago as a number, you know, but infinity, an infinitely large number could be 1 million. And when you put 1 million raised to the fourth power, enough
millions.
that. Yeah, man, enough
Billions or trillions.
Yeah, man. Oh, I would have been that well with some money. But I stopped teach. John no star. I'd live on a beach. But anyhow, let's go. So this is how we're going to get infinity over infinity. Because it is going to be an infinitely large number that we don't even know what that number is. Because remember, you know, if you like in the other question, it says 10 into 1, 2, 3, minus 1, minus 2, minus 3. This one says 10 into infinity. So you lot may use infinity as 10. Crosswell may use it as 100. Jane may use it as 10,000. Courage may use it as 1 million. So each of us will have a different concept about what infinity is. But nonetheless, we will always end up getting the same answer. Watch me. So what I'm saying to you is, in order for me to reduce this question, I'm going to be looking for the highest power in the fraction, in the rational function.
And it's 2x squared.
It is x to the fourth.
X to the fourth. X to the fourth.
So it's not just x to the fourth in the numerator now. I'm looking for the highest term in the whole fraction. And then what I'm going to be doing, I'm going to divide throughout every term by that.
The highest.
Yes. So if I look at it, I recognize x to the fourth is the highest. Look, x to the fourth over x to the fourth. See it right here, so? Then this x squared, then divided by x to the fourth. See it right here, so? And this 7 is divided by x to the fourth. You see it here? This 2x to the fourth is also going to be divided by x to the fourth. This negative 6x squared is going to be divided by x to the fourth. Yes. And this 2 is divided by x to the fourth. So x to the fourth is the highest in this rational function.
It's the highest in the room.
It's not in the row. The highest in the function is what you're going to divide it through by. What you're trying to do is to reduce the function. You're trying to reduce the function because you're going to have multiples in it. You know, I can say to you, 2x equals 4. But I can simplify it and say x equals 2. I can say x equals 2, and I can say 2x equals 4. Because x equals 2 and 2x equals 4 is the same thing. And I can say 100x is equals to 200. X is still equals to 2. Right? So I am just trying to simplify the stuff. So let us work and simplify. So we're dividing everything, we're dividing through by x to the fourth. Look at what happens. These two cancel out. Everything in the numerator would cancel out and just leave an x squared in the denominator. This one don't have nothing to cancel out. So does this one. all the terms in this x cube will cancel out and just leave one x here. And these two cancel out. So this is what it reduces to. 1
1.5
minus
Just
1
go
over
back.
x.
Just go back. Please, just
one
go over
Because
that one again.
no, all I'm saying to you is that I'm dividing through everything by the highest power. So when I do that, then I'm going to cancel out. So this line is my cancellation. So when I cancel, what is going to happen? I'm going to have the x to the 4th cancels out x to the 4th. Talk truth.
Yes, sir.
And then x squared over x to the 4th. It means that all of this x squared can go in here. So this will have 1 over x squared. Not to have x squared there. Because remember, x squared times x squared is x to the 4th.
Yes, sir.
All right. So that's why I have the 1 over x squared right here. So, and then the 7 over x to the 4th can't cancel on in anything simpler. So I just put it back right here. So because there's no x in the numerator. Then this 2 over x to the 4th over x to the 4th. The x to the 4th cancels x to the 4th. X to the 4th cancels x to the 4th, right? And then now x to the 3rd, all of this x to the 3rd can cancel into x to the 4th and leave only one of the x's. You remember x to the 3rd is x times x times x. And x to the 4th is x times x times x times x. So therefore, I can go ahead and I can cancel out all of them and just leave one of the x's. Following me?
Yes, sir.
So far, sir.
Good. If you're not following, let me know.
Sir,
And then
hold on. Lift up by the screen, look well. Let me see it. I understand that those are idiots. Just let me see the top a little bit. Can continue, sir.
all right. Now, so what is going to happen now is that when I do the cancellation, I'm going to end up with 1 minus 1 over x squared plus 7 over x to the 4th because I'm doing the cancellation. And then when we cancel out, this is all that we're going to be left with. Now I want to have a conversation about it with that. 1 minute. All right. No.
Sir.
Yes, Papa.
I have a question. So you have canceled. So I'm seeing in the denominator for the top version of the equation. Right. So 2 over x squared divided by x squared. That was canceled out. But I'm seeing for the 2 with the numerator 6 and 7 and the x at the denominator. I'm wondering how the x reached there when everything was canceled.
Well, which are the terms?
For the 2 over x divided by x squared, x 4th. Yeah, x to the 4th power. Yes, that term. And that
Can I answer your question, sir? Young man. Please not ask your question.
For the term that sir is hovering over, was hovering over right there, for the bottom left, right? That term, he canceled it out. He canceled the x's, and so I was wondering for the last simplification, how did he got an x at the bottom? So for the last simplification, he had 2 over 8 6. 2 6 over x, right? So I was wondering how you got the x in the denominator. Yes, sir.
For
Right
which
there.
one? Right here, son?
Yeah. I
But
wonder
there's no
yeah.
X.
No, I think it's mean like we're under the 6 right here.
X
So, sir,
over
what did
X
you
here,
get?
so sir,
X
where
over
you
X.
get when
Yes, sir.
when you do this X square,
Yes, when you take the 4
X
from
over
the 3
4.
up at the
So
top
you
here,
take
so?
it, yes, because you'd have 3x here and
Yes,
4.
and
So
4x.
3 from 4x would leave you with 1x.
Exactly, and it
So
would
what they
be
do
in
is
the
they bring it
numerator.
to the top denominator.
Yeah,
Okay.
that's my answer. That's my question.
I was wondering, no, but still, I want to know why did you do that up there, not and that's at the bottom denominator. It may seem like a stupid question, but I want to know why.
What term are you talking about? Is it this term?
Yeah, that one.
Okay. So let me spell it out.
No, sir, not that one, sir, but the two.
No, sir asked me specifically.
All right, let me ask you. Okay, so you're asking about this term?
Yes, sir. And
right, so let me work with this term first. Hold on, let me work with that term first. So I'm saying 2x to the 4th over x to the 4th. X to the 4th into itself goes how many times?
4 times.
Huh?
4 times.
So 1 time.
Yeah, 1 time.
Good. And x to the 14 that goes 1 time. And 2 times 1 is 2. And this is over 1, which is the same thing as 2. Which is why I have that 2 right here.
And with that again, sir. Okay.
2x to the 4th over x to the 4th, the x to the 4th is cancelled out. So all I'm left with is a 2.
With the 2. Mm-hmm.
6x cubed over x to the 4th is the same thing as 6 times x times x times x.
Over x.
Over x times x times x times x. Don't it?
Yes, sir.
Yes, sir.
The one that cancels that one there, right?
Yes.
The one that cancels that one they don't.
Yes, sir.
And the one that cancels that one they don't.
Yes, sir.
What am I left it now?
6 over x.
Magic. See what I said? 6 over x.
Oh, sir, I thought the 2 was with the 6 over x. That's what I didn't.
Hello. Do you see this minus thing?
No, sir, I didn't. No.
It's hard to differentiate between that and the fraction. That's why it's so confusing.
So I was confused.
Sir, I just want to clarify. Where you have the 2x, the 2 and the x to the 4th power, I didn't know that you multiplied. I thought that you just put it back there because it's not dividing. There's nothing to divide it there. It has to multiply with whatever remained there.
So that 2 is being multiplied by the x to the 4th. Because if I want, I can show you, say so. The whole number 2 is actually 2 over 1. So every whole number can be written as a rational number. Every whole number can be written as a rational number by dividing by 1. You remember I spoke about rational number in the very first class? Rational fraction. Every whole number can be written as a fraction. All right? So you have to pay respect to the negative sign. Real talk. You can't just see it and think, say, oh, yeah, Pay respect. All right, very important. All right, let's go. Okay, so let me explain something again. So this 7 over x to the 4th, you recognize I don't have an x term in the numerator?
Yes, sir.
Yes, sir.
So therefore, I don't have anything to cancel it down with, so it comes back. This 2 over x to the 4th, I have nothing to cancel out with, so it comes back. All right.
Some respect.
What happened now?
All right.
I want your attention here. You see, whenever you have a constant over a variable, it means that this one and this one and this one and this one will all be tending to 0. And so once that constant is increasing, it's going to 0.
So it would be an indeterminate. So you can simplify it to 0, in other words.
No, ma'am, we already established up top that it's indeterminate, you know.
Okay.
We're not trying to isolate it now in order to get the limit. So if you put any calculator for me, say, okay, let us use the first term. Say this term down here says increasing, because remember I said to you, as x tends to infinity, so it's increasing. Put 1 divided by 10 and tell me what you get.
1 over 10.
0.1.
0.1.
Yeah,
1 over 100.
0.001.
1 over 1,000.
0.0001.
1 over 10,000.
0001.
0.301.
All right. You recognize what is happening to the answer? What is happening to the answer?
So it gets smaller.
The more
and approaching what number?
The more increase of
They're approaching 0.
The more increase the increments, the further it gets away from 1.
Right. So it's approaching 0 every time. So if you put 6 over 10, 6 over 100, 6 over 10,000, 6 over a million, 6 over 10 million, that's what is happening. It is tending to 0 every single time. The numerator is not moving, it's just the denominator alone. It will always tend to 0 every single time. Today, tomorrow, and always. Very, very important. So watch what I'm saying to you. Let us look at a little proof. This 1 over x squared, you see exactly what I was doing here? This one goes to 0. But look at this one here. Compare this one to this one. This one went to 0 faster than the other one. Talk truth.
Yes, sir.
Because they say 1 over x squared, you have 0.01. And then 7 over x to the 4th is 0.0007. So this went faster to 0. This one is the slowest that it went to 0, don't?
Yes.
And if you want to look at it here, you can recognize 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 zeros right there. Let's check how many zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why this one has 11 zeros and this one have 11 zeros? Because...
You share a count properly, sir?
Yeah, man. 11 zeros after the decimal point. Why this one have 11 zeros and this one also have 11 zeros?
4.
Because they are both going x to the 4th. They are both going x to the 4th. So this term, as well as this term, are moving to 0 at the same rate. You see it here? You see that reach the 10,000, both of them go to negative 16. So they are going to 0 faster. The next one that is going to 0 faster is this one here, and then this one is going to 0 slower, right? Because this one is only x. This one is x to the second power, and this one is x to the 4th. So this is just a proof to show you, once you have a constant in the numerator and the denominator is varying, your term is going to run to 0 every single time.
But sir, I also noticed say that the first in that table, you're multiplying the powers by negative 4 each time.
1, 2, 3, 4,
Yeah, yeah,
So like with 1
yeah,
over
yeah,
x squared, you multiply
yeah.
you multiply that by 4 and get -8. The
Yeah,
same thing over x squared.
if I never work it out like this in the table, you wouldn't see that pattern. But yes, you are correct. All right, watch me now. So I'm saying to you, if all of these are going to 0, look at what I'm going to have here. I'm going to write this here into this form, and I'm going to say that this go to 0 and that go to 0 and this go to 0 and that go to 0. So all I'm left with is 1/2. So that's what the limit tends to. And so Lottie, you understand why I have this 1/2 here now?
Yes, sir.
Yeah, because the limit tends to 1/2.
1/2.
I want you to look back at
So the
this.
answer there so long time.
Yeah, man, answer that at the start of the question long time. But we're going to go through an exercise, that I want you to see what is happening. So look at number 7 for me. Look at number 7 from start. I'm going to give you an opportunity to look through at number 7 because you're going to do some classwork for me today now. Look at number 7. Take about 2 minutes to go through, internalize it. Then I'm going to move to the other half of the slide, give you another 2 minutes, and then we're going to have a conversation, and then you can start one for me. On the mark, get set, go.
Sorry, what kind of approach is this?
So I'm actually using, it's a calculations approach, and I'm using the algebraic method. So the intuitive method, done. The intuitive method, done. All right? So, and if you're doing this, I'm going to talk to yourself. I'm going to ask you to mute so that you don't disturb others, because I want everybody to get an opportunity to go through this. If you have a question, please unmute and ask me the question. But I'm going to give you 2 minutes at the first so that you can look through this from start to up to the point you see on the screen. All right. How do we feel so far? Can I move?
Yes, sir.
All right. And then now, when you finish look at that, number 8, I want you to try. I tell you the answer is 1 for number 8, but I want you to try it on your own and tell me if you agree with me that the answer is 1. So take another 2 minutes. Good job.
Sir, what do you mean press F and then press D? What are I pressing F and D on?
No man, I was just showing the algorithm for evaluating some of these values in the table. You can ignore that. You can ignore that line. I was just showing the algorithm because some people may not know how to evaluate all of these stuff here. So you can just ignore this line.
Sir, can you bigify on number 8?
Sir, I'm stuck.
Where are you stuck? For which one? For question number 8?
Yes, sir, for question number 8.
Okay, what's the problem?
Sir, I did the wrong thing. Never mind. Sir, I put X instead of X to the third.
Which term are you going to divide throughout by?
Sir, what did you say?
Which term are you going to be dividing throughout by?
Sir, I'm not following what you say.
Can somebody answer that question, please? Which term should she divide throughout by?
X to the 4th.
X to the 4th.
X to the 4th. Very good.
Sir,
Can you also not tell her why she needs to divide through by X to the 4th?
Sir,
Because
It's
it's
the
the
largest
largest.
term, the biggest term.
Very good. Continue working now.
Sir, I'm stuck again.
What happened?
Sir, when I have the X to the 3rd over X to the 4th, is it like 1 over X, right?
Duh. Very good.
Sir, I'm just gonna ask.
Very good. Continue. And I want you to ask. Let me tell you, say you're wrong. Very good. The rest of your work.
So finish with question 8. I'm not sure of my answer.
What do you give for the answer? Courage.
1.
So my one beside it there. You know, say the one beside it in the red. Very nice.
Is that the answer? Oh.
Yeah, man. You're gonna buy one Tiggers too. You know what? By the way, you know what Tiggers is?
See what?
Tigers. See, you don't even know it.
Sir, when I reach the
Yes,
second
Papa.
stage, all right.
Hold
so
on,
sir-
you know, me encourage a talk about food. Courage. You know what tigers is?
No, sir.
All right. Look how you can buy your bag and give it to you here. Okay, so we just say to Power to go Lottie. Crosswell, your turn now.
Right. Yeah, I'm doing the thing. Like, so I reach the second stage, and I set up like the denominators for both the upper half and the lower half, and I and I do like what we call it, the cancellation. So it's just something that I'm trying to remember, sir. So I did one, which is one extra, and I cancel both of them, and I did the second term as well. So is it that I bring over the second term to the first term, since both variables within are cancel, and so it would be one minus the second term. Okay.
Come on.
Sir, I got one.
You got one. Very good. Anybody else get one for the answer?
Yes, sir.
The
Very
common
nice.
cut said.
Anybody get any answer away from one?
So check the chat.
Or check the chat. All right. Thanks for helping me out. All right, come on. Talk to teacher.
Sir, sir, I got 9 over -9 over x. I don't know why that is.
I'll get knock you silly. I'll get shake out your lunch money for tomorrow. Or you get 9 over 16. Talk to teacher. Where do?
Sir, so after I did the cancellations with x to the power 4, I got 1 minus 1 over x squared minus 9x. And
no, sir. You can't get 9x.
Sir, I fell into the same trap, but I realized something. And,
tell him what I'm supposed to do.
Well, you should completely remove the x after the what is called cancellation.
Sir, I'm stuck.
We are playing stuck tonight. All right, no problem. Long time in a play game.
So, okay.
Continue, Carlington. Erlington. Oh, Carlington. Erlington, continue.
Sir, I don't know where I did wrong. Where did I go wrong?
How much you have to lose? And you can't say nothing. How much you have to lose? Talk to me. All right, then think about it. All right, let's go. Let's go.
Yeah, hold on, baby. Sir, I'm stuck. What?
Never mind. Never mind. Watch me.
Hold on.
All of you watch me. All of you, including those who would have gotten it. All right, so my x to the 4th is going to be what it is that I'm interested in. True or false?
True.
Repeat.
I'm saying x to the 4th is a term that I'm interested in. True or false?
True.
True.
Because it not only appears in the numerator, it appears in the denominator. Sir, will it always appear? Go ahead.
Sorry to cut it. So what if a person use x to the 3rd instead of x?
Them wrong. Them wrong from the start. Them get 0.
X to the 3rd.
If you start with x to the 3rd, you need to go to the ophthalmologist because sir, they say at the highest power. So if you start with x to the third, you don't have no mark to get for the question. All right, so let's go. So the only way, the only time you're dividing through by the highest term is when you have to the infinity. Not get no other question where extending to 5 and to 4, and then you decide, no, say you're right, and you're going to divide it like that. You're wrong. 0 from the start. Only when you have infinity. Only, sorry, forget that, you're a bright student.
Only when you have
only when you have x tending to infinity. Watch me. So I'm going to have x to the 4th over x to the 4th minus x squared over x to the 4th minus 9x to the 3rd over x to the 4th. So it's why it is that you couldn't get 9x x to the 4th over x to the 4th plus x cubed over x to the 4th. Watch me now. This goes into this exactly and leave 1. All of this go into that and leave 2. All of this go into that and just leave the x. This just leave 1. All of this go into that and have 1 in the numerator.
X squared.
And then we have 1 minus
Square minus 9.
Sir.
Yes, Poppy.
That's what
You look like you mark out the 9 up at the top.
Sir, that's
right,
what
the 9 right there.
But me can't mark out the 9. Think about
But
it.
that's what I was getting ready to ask, because the red line goes over the 9 a while ago. So that may I ask why mark right.
Sir,
you.
The part where I went wrong, sir, is the numerator with 1 minus 1 over x squared and 1 plus 1 over x, sir. I thought that they could go into each other, sir. That's what I did. What can I say? I divide them into each other. That's how I got the 9 over x. But I don't know, sir.
All right, question now. Come on, you see the mistake?
The quotient and something. Maybe I get a mistake too.
Come on, talk to teacher. You see the mistake that you made?
Yes, sir. I have that, sir. I have that.
All right, so watch me now. So watch me now. I want all of you to watch me. This as 1 over x squared, 9 over x squared, and 1 over x tend to 0.
Is 9 over x squared?
As x tends. Oh, sorry, it's 9 over x,
sure
right?
It's x squared?
No, man, I mean, I just put it here to see if you're paying attention.
You sure it's not a mistake, sir?
Huh? Say it again?
You sure it's not a mistake?
No, man, it's just that I wanted to see if you were paying attention. Father God, forgive me. Right? So as x tends to infinity. So as x gets large, all of these here go to 0. As x tends to infinity, all of that go to 0. So what I'm now going to have is 1 minus 0. This gone to 0, that one gone to 0, minus 0, all over 1 plus 0, which is equals to 1 over 1, which is 1. Do you think that is difficult?
So it's just that probably our brains are still wrapping that part around.
Okay,
as
no
x
problem.
get to infinity, whereas the 9 is.
Yeah,
Because we all stuck right there where the 1 minus 1 over x to the second power. We all stuck there, but we're wondering what to do next if we're supposed to minus or divide and cancel though.
No, sir. That's supposed to be infinity. So as that
Sorry, could restate the rule when
So sir, what makes we know what goes to what give us the infinity? What oh we know that?
Yeah.
What let me try to process that question.
There you go.
So you have a constant in the numerator and a variable in the denominator. So that's how you know you're going to go to 0.
So if there was a number in the denominator, a number and a variable, can that be possible?
Yeah, but it may go very slowly. But in a case like this, you will, yeah. I'll get answer yes, full stop. When I get to somewhere else, I'll come back to you. You understand what I just said a while ago?
Sir, my brain just now wrap around it. I see what you did, but
it's breaking your brain.
Right. I need there's one information we might need to connect it to bring it home. Probably use a different word or word.
Sir. Alright, so sir, with the last part of the calculations, you said that each of the values are getting closer to 0, right? So so in that case, for me to wrap my head around it, I'm just assuming that everything that isn't 1 in this calculation will be 0, and I'll use that, and I will just substitute those values for 0 and use that to get the final answer. Because any other way, it's still, if I think about it any other way, it's still confused. It still hurts my head to think about it.
Okay. All right, Nikki, I'm going to ask you to do me a favor.
Listening.
All right, cool. I'm going to ask if you can isolate yourself, because I think you are the noise around you is somewhat. I think you're hearing conversations around you, so you're just giving me one ear, and that's why you're not fully seeing it. And I know it may be difficult, but and I mean, if anybody else is like that too, I'm going to ask you, see if you can isolate yourself. If you can go lock up in the bathroom, you can go in out the closet, you can go lay down under the bed so them can't find you. But
yes, sir, if I do that, I won't have the internet. I'm gonna have the break-in, and I won't hear anything. Yeah, but it's just for a few days, sir. But I'm tuning 100%. I'm tuning in completely.
All right, cool. I'm gonna re-explain it, and I don't want anybody to think at all that whenever you ask me a question that I get annoyed. This is a part of learning. And sometimes I may give you a little cheeky answer. Don't feel no way about it. It's just to add a little humor to the class. It can't come in my class, I'm boring. Crazy? What's up? So we're going to be energized in all activities that we do. I'm going to walk you through the question again. What I'm saying to you is, when you get a question, it says the limit as x tends to infinity. Once you hear infinity, no seeming for look for the highest term, and then I'm going to divide through each term by that highest term. Why, sir? Because I'm reducing the rational function. I'm reducing it. So when we reduce, I make it get smaller. So every term in the question is going to be divided by the highest power. The term with the highest power. The term with the highest power. And guess what? The term with the highest power don't have to both appear in numerator and denominator. It can only appear in one, either the numerator or the denominator or both. All right. So if in that question you have x to the fourth in the numerator and denominator, but it also had x to the fifth in the numerator, which one would you divide by?
X to the fifth.
Very good. X to the fifth. All right. You're divided to the highest power. The highest power. So therefore, x to the fourth is the highest power. So each term is going to be divided by x to the fourth. Now, the mere fact that I'm divided by the highest power will suggest, based on a question that was asked earlier, I don't know who it was, will suggest that I will never get a variable in the numerator. Sir, why? Because I'm dividing by the highest power. Once I divide by the highest power, it says to me that I will never get a variable remaining in the numerator because I will have the highest power in the rational function placed in the denominator. So every power in the numerator will cancel out every single time. This is just the nature of how the question is set up. So you will never have 9x over x squared. It means, say, you never did a complete cancellation. So in this case, you'll always have a constant in the numerator and a variable in the denominator. Once you have a constant in the numerator and a variable in the denominator there when you do your division, it means as x tends to infinity, everything goes to zero. Everything there goes to zero. As x tends to infinity, all of the term there, oh crap, I don't want to do that. As x tends to zero, all of the terms go to zero. All of the terms tend to zero. Every one of them will tend to zero. All right? Now, work with me still. So in that case, I'm going to have 1. Anywhere I see the fraction, we know it will go to 0. Which if it go to 0 fast or it go to 0 slow, it no matter, it still go to 0. You know, the truth of the matter is some people may say, oh, you have a BMW, but you have an old BMW. It no matter, old or new, it is still a BMW. Right? It no matter. So some of the fractions may go to 0 fast, some of the fractions may go to 0 very slowly. It doesn't matter. So I can tell you the 9 over x will go, the 9 over x and the 1 over x will go slower than the 1 over x squared. But guess what? It is going to get there. Some of you may understand the first time, sir, the first example. Some of you may need 5 more examples. Guess what? As many examples as you need, you can find the example so that you can understand it. Let's go. So true, because all of them can go 0. You can put 0 right here, so I'm circling the blue. 0 right here, so again. 0 right here, so again. What is going to be left? You're now going to have 1 minus 0 minus 0, see here, so? Over 1 plus 0, which is 1 over 1. Your answer is going to be 1. Talk to teacher.
All right, so for clarity. All right, so when you said, what do you mean by saying going fast or going slow? Are you referring to how fast you can divide?
No.
You can break it down?
Remember this one, this little table I show you here? That the 1 over x, when you have those x alone in the denominator, it goes to 0 slower than when I have x to the 4th. So I'm not saying to you that the highest value, the bigger x value you have in the denominator, the larger the value in the denominator is the fastest it will go to 0. So that is neither here nor there. I was only showing you something pictorially so that you could imagine it. Right? So it doesn't matter how fast or slow. All I would say to you that you notice I never did this table up here. So for this question, because I would have made my point that irrespective of what, this one goes to 0, this one goes to 0, and this one also goes to 0. So I'm going to have one that when you add one to when you add or subtract 0 from 1, your answer is still 1. 1 plus 0, your answer is still 1. And then now that is going to be 1, which is your final answer. That's going to be your final answer. All right, watch me. I ask a question, can you do that by inspection? I am saying to you that the answer is supposed to be 2/5. I'm going to give you an opportunity to work the question for me. Me not talk about no slow working. I want fast working. Know that you know how to do the question. What are you going to divide through the fraction by?
5.
X to the 5th.
X to the 5th
Not 5, but
X to the 5th.
F to the 5th. Right? Not 5, but X to the 5th. 1, 2, 3, go. Start.
Sir, I'm stuck.
Pull.
Sir?
Pull.
Sir, I passed the part where I work out the term use and I got that. But when I put in it to like up here where you say 1 minus 0, sir, I don't know if I must put the 9 times the 0 and all of that. Sorry.
Jojo?
Yes, sir.
Ask the question again, please.
Sir, I'm not sure if it should be 9 times 0 or just put the answer to 0.
9 times 0. Why would you get 9 times 0? Where you get 0 from? The question for infinity. Where you get 0?
Sure.
All right, so very good, Carlington. Erlington. Erlington, very good. Tajay, very good. Chedi, no, oh, Chedi, yeah, man, who that know? Okay, very good, Joe. Hey, your swag turn up, you know. We don't know why you direct message me now, but your swag book, very nice, love it. Yes, TT, Miss Tab TAB, very good cousin. Crosswell. Who else? Talk to me. Yes, Terry, good. And I'm going to ask you the question again. Why 0? Very good, Dan. I'm going to come back to you now, Jay. I want to know why 0. Dane, you know, talk to me. Christopher, you're not speaking.
So I'm still trying to work this one, number 9.
All right, well, hurry up, man, Papa, hurry up. Azra, come on, I don't hear from you.
Yes,
You're
sir.
not, you know, talk to me, man. Oh, what one?
Sir, I'm working it out. I'm
All right,
almost finished.
All right, nice job.
I'm sorry, I got it. I got it 2/5.
You got it. Very nice, very nice. I only one tickets I get. Do your mommy? You not get more than one. But very good though. Sharifa, you have not spoken to me since ever. Christopher Coke. Sorry.
Sir, that's a lie. I'm the first one to make a comment in the chat.
Sharifa, I want to hear your voice. So, oh, you know,
I
me
don't
can't
have
read.
time for the unmute button. You
can't
can
find it on
read.
me. I can't read.
You
I
can
can't do the
read.
maths.
You are teaching maths, you most can read.
I see you think. Leon, are you still so? Unmute and talk, no?
Sir, I'm working, but
Over 5,
I
sir.
don't know where I'm getting some of this.
Good
But
job.
when you're getting there.
All right. Hurry up. I'm not moving because I want to make sure that you understand. Crossdale, talk to teacher.
Sir, I'm still working, sir.
Is this Raggy? Mr. Rowe, how you pronounce your first name? Shana, how you stay? And Miss Katie keeping secrets from me again because I'm not seeing it even. Listen to me, Mama. I want to talk. Okay. All right, so I give you 2 more minutes. Those who said that they're still working, not 2 more minutes, 1 more minute. I give you 1 more minute. Those who are still working, 1 minute. And then after today's class, we need to put some pep in our step. Because if we don't, the train is gonna leave us. We have a lot to go through. Ashanti. Ashanti. Ashanti.
Sir.
Yes, please.
I have a question to ask you
Go
two.
right ahead.
When I was in Educosol, there was a question I came across and
Mhm.
I couldn't solve despite seeing the answer. I couldn't get the answer. That's the x approaching 0 and the fraction is sine x over x.
All right. Again, come back to that sign X over there. Again, come back to that sign something.
Okay.
Yeah, man. Thanks for telling me. I'm going to come back to that. Ashantio,
Sir,
listen to me. If I call you, want you answer me here? You're too close to me if you don't answer. I say you're too close to me. When me call me, I have to call you 5 times. Are you following Honey Country?
sir, is in my Educosol alone not showing anything?
Yeah, I'll work on that. I'll work on that. Ashantio. For the 5th time in my class tonight, Ashantio.
He's talking in the chat, sir. So I don't know if something is wrong with her mic.
I can't read. Sorry. You know what I talk to me. Thanks a lot. I know the truth. Does not want to talk to me.
Answer, sir.
I know what I know. I know what I know. It's one of them days they see. Come on and say, sir, how you doing something? And sir again sit down there and sir again listen to come on. Sir, are you there? And then again say, but why sir was there and sir don't answer? It's not even cute for when somebody's trying to have a conversation with you and the person is calling you and you're not responding. It's really not cute. Really not cute. So if you're going to say to me that you don't have what do you call it? You can't unmute. Suppose you want to ask me a question. Is me must go read the chat while I'm teaching you to go find the question and respond to you? No, you have to get a device that you can use the audio. I'm sorry. That's why I say I can't read. I'm not doing it. Very sorry. Negative. All right, let's go to those who want to talk. All right, so what it is that we're doing, we're looking for the highest power. We're looking for the highest power in our rational function, or the highest power in our rational function. When we find the highest power, we're going to divide throughout by it. As I said before, just remember, because the highest power will be in the denominator, there is no way at all, absolutely none, that when you do your cancellation, can you have a variable in the numerator. Will never work. Will never work. All right? Will never ever work like that. Will never ever work like that. So I'm not working the other one here. I'm going to do this one because I sense that some people not following so well. So I'm going to do this one. So I'm going to have 2x to the 5th minus 9x squared minus 7x, and I'm dividing throughout by
X
to the 5th. Come on, x to the 5th.
Mhm.
5 over x to the 5th over x to the 5th. Come on. Plus 2 over x.
Mhm.
X to the 5th. Watch me. Nikki, I want you look on this now because when we cancel up, it said, sir, it never go over to something. The x to the 5th here. When you cancel that x to the 5th here.
Leave 2.
I'm not gonna leave me with 2.
Mhm.
Watch me now. X squared, everything in a x squared, then go in a this 2 times and leave how much remainder?
3.
Good
3.
job. Very nice. So I'm gonna have minus 9 over, come on, over x to the 3rd power.
Mhm.
The x will cancel into this and leave how much?
4.
7 to the 4th.
Good job. Not 7 to the 4th. 7 over x to the
X
4th.
to the 4th. Yes, sir.
Good. All of this cancel with all of this. Then leave it just 5.
Plus.
Plus all of this cancel this into how much did we?
4.
Good
2.
job. Good job. So we have 2 over x to the 4th.
The 4th.
Nice. So I'm saying to you, as x tends to infinity, 9 over x cubed, 7 over x to the 4th, and 2 over x to the 4th all tends to 0. This line is important for you to write. And then when you say that now, you're going to have just 2 minus 0 over 5 plus 0, which is going to be equals to 2/5. So you see, there's no way you're going to get a number to multiply by 9 times 0.
Sir, hold on, sir. Sir, so that the 9 times 0 is incorrect. Sir, but
Because
even though the 9 times 0 is incorrect, I still got the 2.5, the 2 over 5.
No problem. No problem. That's fine. Not a problem. Look how many times you make mistake and look how much time you take on wrong road, but you end up reaching somewhere. Yeah. That don't mean nothing. But I want you to follow the correct step. Let me tell you why your step is incorrect. Justify for me how you substitute 0. Why you put 0 into it? Where you get 0 from?
Sir, I knew where I went wrong because
no, man. Answer. No, hold up, Jojo. Hold up. Answer me question. No. You see, I don't want you to tell me where you went wrong. I want us to arrive at it because where you think you may have gone wrong is not where you go wrong. So I want you to work with me. So may I ask you, tell teacher, where did you get that 0 from?
Sir, I thought because x is tends to the infinity and it will be
Stop.
Okay.
So you're saying to me that 0 is an infinitely large number?
No.
That's the point. So this is why I stop my class and I call upon students, because I want to be able to get into your headspace.
Sir?
Yes, Papi.
Sir.
I'll come in. Let her finish her thought. Go ahead, Jojo.
Sir, what I did was separate the 9 and the x to the 3rd. That's how I thought it was wrong because I was asking you what I must multiply. So that's where I went wrong.
Okay, all right. Hold on. So what sir gave you was you separate. Hold on a minute. This is getting nicer and nicer, you know. This is what you say you're separating?
Yes, sir. That's what I did. I put 9 and then I put 1 over x to the 3rd.
Okay, so you put 9, 1 over x to the 3rd. All right, and?
Sure, and then I put minus and then I put 7 And
Yeah, 7 and the same 1 over x to the 4th, eh?
yeah.
Yeah, man. Okay, fine. So we get that. Tell me, you get, what's the next step from here? Or you finish the part here? Because this part here is correct, you know. This and this are the same thing. But tell me now, or you get the, or you move from this to get the 0 now.
So the x to the 0, I just followed what I did before. Like before you had x and 1 and over x to the 2nd to the 2 to the that, and that equals 0. So that's what I did for that. And after I got the 0 and then multiply the 9 by 0 and got 0, and then the answer equal to 5.
Illegal. Illegal. Let me ask a question. In looking at the infinity over infinity, have I ever, in the 3 questions I've done, have I ever substituted a value for my variable x?
No.
No, I haven't. No, I haven't. No, I will not either.
The whole thing you said is that these values in particular
Tends to 0.
tend to 0.
Yeah.
So
But I've never substituted. It's like how we would have done the limit as it goes to 3 and 4, and then I assume that x is 3 and x is 4, and then I substitute the values there for x. When you reach infinity, you can't do that. Not gonna happen. It's another level. Put it this way.
So, sir.
Yes, Poppy.
So in this case, if these values were negatively going infinitely, would the value get closer to 1?
No. No.
Okay. Can you explain why?
And I will explain to you as I go along. In another couple of minutes, incidentally. Lottie, let me trouble you. Play at work and we know why you drop asleep. So come, unmute Lottie. See, she's on sleep now. Lottie. So Lottie gone. Nikki, you about? Weird. I'm muted. Michael, unmute.
Sir.
Yeah, all right. Let me answer a question, Michael. And tell me if you agree with me. On a night like tonight, when you just reach home and hungry or walking on you, and you do a flash out, would it be the same thing?
You do what, sir?
You do a flash out.
What?
You don't know what I talk about? Anybody know what I talk about?
Something with bread, sir.
Mackerel, sir.
Yes,
Okay.
man. Yeah, man. Yeah, man. Because I want quick something to look for.
Yes, sir.
Versus on a Sunday, when you are doing your oxtail. Tell me the truth, it's a different grade of cooking at don't.
Sir, it is.
Yeah, man.
You put in more effort on Sunday there,
which is the point I'm making. So the question that we're doing is high grade, not the one that the robot in the hand middle, but it's a higher grade mathematics than the little one they made us can substitute the x value, x to be equals to 0, 1, 2, 3, whatever the situation is. This year one is high grade. You're not doing any substitution. It's more reasoning than anything else. It's more reasoning than anything else. All right? All right. I'm pressing pause. I want to make sure that you're understanding. I'm giving you a couple of minutes. Questions 10 and 11. Start working both of them for me, please. 10 and 11. Quick and fast. 10 and 11.
Sir, I'm starting to notice a pattern.
Don't talk. Pull up. Read this for me, please.
Can you do this by inspection?
All right, because that's exactly where I want to get you guys to start working the questions by inspection. All right, so you go and do what you're supposed to do. Don't talk the secret yet.
Sir? Sir?
Give me a minute, please. Hello, go ahead, Camilla, please. Okay, Crosswell, I'm seeing a response. Very nice, very nice.
Sir.
Very nice. Yes, please.
You have a line phone, sir?
Yeah.
They ever send you messages about say you can win you can win some money if you participate in this competition and something like that?
I've never responded to those. I've seen them and I've seen WhatsApp messages in that regard, and those are just spam. They want to get into other things on, hacking to your phones. I've never responded to. Well, let me not say I've never. I have, and then I stopped responding to them. What happened? You're saying that I should?
No, it happened to me already.
I don't respond to them. It's just another way for them to get into your password, into your bank account, and get into this and get into that. Well, you guys should tell me more because you guys are computing specialists, so them can't trick me again.
Me never say me use it. Me just said me see it on phone all the time.
Yeah, me never say use it neither. Me just tell you say them can't trick me. Sometimes it may be legitimate, but if you want to give me a prize, just go in your database and tell me I must come collect the prize. I never go through no long rigmarole and spin one wheel. And matter of fact, based on my belief, that is gambling, and I don't believe in gambling, so I can't participate in it. All right. So I'm seeing one or two responses where you say, well, there are scams all over the place here. So just be careful and be careful which machine you put your card into. All right. Yes, Chedi, I'm seeing that. Very nice. Tariq, leave Cresswell alone. What about the others? There's so many of you in the class. I'm very worried, I'm very worried. The class is large and is the same set of people responding to me. Same set of people responding to me.
Mexico draw.
I may give you a test next week, Tuesday, God's willing. This is what I can find out if you really understand it. What do you get for number 11?
Sir, I don't really understand number 11, but
I just reached number 11 right now.
So I'm going to
Jojo. You'd have done several questions. Number 11 is the same question like the ones they've done before. The same something that you have been doing. They can't tell me so you don't understand it.
Also, I'm not seeing number 11 fully.
You're not seeing number 11 fully? All right. Hold on, Papa. There you go.
So I get 2 for number 11.
You get 2. Lottie, is you that? Who was that a while ago?
Lottie, sir.
Hey! Wait, eat for lunch today?
Thing.
No, you can't say nothing.
I can't saltfish.
Eat it tomorrow again. I mean, if you're right, you know what me like how you're patiently at work on something very nice. How confident are you?
So I would say both answers for number 11, one on the screen and one that we're getting is correct.
There's no answer for number 11 on the screen.
Indeterminate?
That's not the answer. That's not the final answer.
Who did you got to here? Disappointed. Painful. No, it's not. Of course, you have to get the final answer. The final answer comes. One of the final answer comes.
Come on, I'm reading for the rest of you now. Quickly. Come on, man, quickly.
Sir, I have a question.
Go right ahead.
Sir, what if you work out an equation, right? Sir, and all of the top numbers equal to 0 and the bottom number equal to like 2 or somewhat, what you call that? And it would be equal to 0/2, something like that.
But if it's 0/2, no, something.
It will be 0 over?
So it will be 0/2. So I'm wondering what you do if it's 0/2.
If you get 0/2, we get that. What is 0/2?
Sir, I'm asking about if you get a question and so like the 4.
No, I heard a question, you know. I heard it. And it's a plausible question. So me asking if you get 0/2, what the answer is.
0.
0.
Oh, okay.
But if you get 2/0, what is the answer?
2.
No.
Math error.
Math error. Tell them why, Cherish.
So you can divide 0/2.
A 0, yeah. So 0 cannot exist in the denominator, yeah. This math error, we call it undefined. We call it undefined.
Sir, because 2 cannot go into 0. There's no 2 in 0.
You can't have a 0 existing in the denominator, that's all. So you cannot have a 0, you can have a 0 existing in the numerator. One of the things that I keep saying to students, I can put a circular stone on top of a house, but I can't build a house on a circular stone because it means that it's only at the center of gravity that I can step on that stone, or else the house being topped over. All right, so you cannot have a 0 existing in the denominator. You can have it existing in the numerator. Once you have a 0 in the numerator, your result is going to be 0. But if you have a 0 existing in the denominator, it's going to be undefined. Math error. Can't be solved. Feel and come again. All right. I need to hear from the rest of you. What say you for the answer? Oh, I'm using 2 devices. You hear I'm logged in twice. And
riveting.
Some of you are sending the messages. So I don't want. So why are you giving me 4/2? What is 4/2?
So the answer is 2, but that's what I
Right.
got the 4/2.
So always give it in its lowest form. Always give it in its lowest form.
So, sir.
Okay.
What do you think of a new?
What do you think of a who?
Of a new world.
A new what?
New world, sir.
A new world?
Yeah.
As long as it's going to be where them never eat the apple, and no more sin, and no more sickness, and no more stabbing on the neck, and no more fight, and no more no more sickness, and no more death. Yeah, I'm gonna do that.
So that's for the new world order.
No, that's different.
That's why I didn't complete the sentence, you know.
No, but I mean, you can't ask me half a question, never get half a answer. Half a question, give you half an answer. Let me reduce it. Oh, crap. Ouch. Let me get rid of these. All right, so what I have here are my steps in.
How do you do that?
In doing the. So my answer is 2. My answer is 2.
Oh, so you were teaching a class before us.
No. Remember when I was writing earlier, and when I was writing all the 5s, and it kept missing out, and I had to be rewriting over the stuff. The orange 5 here. Yeah. When my writing pad is dusty, that's what happens. So I just have to clear it up. All right. Good to go now. So yeah, every time we're doing the same thing. We either define the highest power. The highest power does not have the trick in this question is the highest power does not have to be at the start of the question. The highest power can be in the middle, or it can be at the very end. You look at it, the highest power is x to the 6, and then I'm going to divide through everything by x to the 6. Follow the same rules as all the fractions will go to 0 as it tends to infinity, as the variable x tends to infinity. So I'm going to have 0 plus 4 minus 0. 4/2 is going to be equals to 2. Very good. Lottie, trust me. I'm proud of you. You were first out of the ballpark, and you hit it well. So I can saltfish for lunch tomorrow again.
Sir,
what is the answer for this one? I'm not telling you what the answer is. I want you to look at it and tell me what answer it is for this one.
First, -7/9.
-7/9. Do you agree? We're not working anything. We're
Oh
looking
yeah,
at this
yeah.
stuff.
Agree, sir.
Yeah, agree.
Agree? Negative 7/9.
Yes, sir.
Yes, sir.
Cause
No,
since
sir.
I
Sir, that
okay.
is a lie. It's not -7. Sir, sorry.
Okay. Cherish, what do you think it is on? Courage. What's that mean, cherish? Courage, what do you think it is?
Sir.
Let's see.
I'm not
Since the
sure yet.
highest value is
The highest is 5. X to 5, huh?
Sir, I have in my head 0/1.
You having it what?
0/1.
0/1?
Yes, sir.
Okay. And what to get for and what is 0/1?
1
0.
0, sir.
0.
Are you sure about that?
You want me to take out the calculator now, sir?
Yes.
Sure. Okay. So Courage say yes. Anybody else agree with the 0/1?
0/1 is 0.
Which is a question that Jojo just asked, and I answered her. That's the question that Jojo just asked, and I answered her. All right. So, work with me now. So everybody agrees that it's 0/1. Who don't say that?
Sir, I got 0/1.
You get 0/1.
Sir, when I work it, I get 0/1.
Oh, you cheat and work the question. All right, cool. You work the question fast.
So,
all right, no problem.
So in any case, the highest value is x to the power of 5, and without doing anything, there none of the numerators at the top have a power that is equal to x to the power of 5. So we can rule them out, because in any case they would be going to 0 in that case.
Very good.
In the bottom denominator, you have a value that has x going to 5, and if we divide it by itself, we would get 1, and then the value next to it, which is 9x, doesn't have that. So if we were to do that calculation, we would get x 9 over x to the power of 4, and since that type of value would lead to 0, it would be 1 plus 0 over, it'd be 0 over 1 plus 0, which will give you 0/1.
All right. Everybody agree with Crosswell?
Yes, sir.
Nikki, you gonna sleep, you know?
But sir, Crossword said up the top would be 0. Said the top will be 0 based on you don't have a x over 5 up there.
X to the 5th.
X to the 5th up there. And then you know that x to the 5th would cancel x to the 5th.
One
know
time.
that leave one. And then, I understand now.
Sharifa, you agree with Crosswell? Come on, you agree?
Yes, sir.
With the 0/1?
You agree with the 0/1, Sharifa?
That's what you're asking me, right?
Yes, only one, two.
That's what I was asking you.
Yes.
Okay, good job. Michael, you agree with what you agree with Crosswell's explanation, and do you agree with his answer?
So I wasn't paying attention to him. So I was trying to still work on number 10.
Okay, yeah, well, you have to move it earlier, because he just said something that sounds like it makes a lot of good sense, and that's why I want to focus on that. Tariq, you agree with what Crosswell says?
Yes, sir. I agree with the 0.
100%?
Yes, sir. 100%. I believe
100%.
All right.
Tony, or you stay?
They called me?
Yes, ma'am. May I ask you how you stay? You agree with Crosswell's explanation?
Yes, sir.
You think it makes sense?
Yes, sir.
One more for the road. Nikki, you gone? Win, or you stay? Shana, or you stay?
Sir, I have to move away from my computer now, sir. I have to look about my son.
Shana, how are you? How easy was that? Very good crossel. How easy was that? And this is what I want you to do. All I want you to do is just focus and just pay attention in class. Sir, going to the questions. You just try to work with sir. And after a while, because you're paying attention, you will see the pattern. You will see the pattern. You will see what sir is talking about. You will understand what sir is doing. It's not hard, but you have to pay attention. You have to turn up from a class. You can't just come. And there's going to come a time, because I'm watching those students, that when I call up and you don't respond to me, I'm giving you enough time, because I'm going to start putting people in breakout room, in waiting room, and I call upon you and you don't respond to me. And I've said it before, and I'm not even getting hurt up my head tonight about it. I'm not getting hurt up my head tonight about it. I have to do what it is that I have to do to make sure that you're learning. That's what the college pays me for. And that's the contract that I have between me and you. You're going to teach me, you're going to understand, I'm going to learn, I'm going to pass it. But if me can't my end of the bargain and you don't do your part, you can't talk to me at the end, because you never fulfill your end of the deal. But that's very good though. Excellent reason, Coswell. Excellent reason. Excellent reason.
One of them said that there was a pattern there. So when he said to do any don't do any calculations, and one of them said 7/9. I just answered it because I wasn't really paying attention, and then you said to actually look at the question properly, and I realized the pattern.
Very nice. Tell me what, I want all of you to look at that one, number 13. Tell me what that answer is.
13.
Sure, definitely zero.
Definitely zero. Why? Because we didn't have what?
8, sir. I didn't say that.
Wait, on. Let me just check again.
I want the rest of you to come in. I just don't want the familiar voices that I'm able to identify in the class. I want to hear oh Jesus. Lottie, you're gone, we're losing her, Lottie.
No, sir, I realize it's zero, sir, but by time they don't say zero already.
Okay.
But the highest is 8, sorry, and
Very
8
good.
not at the top.
So you can have 0 for 1 again, so it's going to be 0. All
Yes.
right. What's the answer for 14?
14, let's see.
Let her finish right off the questions because I'm still going to work them. So just let her write off the top. Just go a little bit more for me, please. Thank you.
No problem.
Sir, you know what I want to ask you, sir? When I go on EducaSoft, is what we're gonna see, is it different from what you're teaching us now? Because I know
sure.
You said sure, sir?
I did not respond to you. I did not respond to you. Go ahead, ask a question.
Supposed to be
No, somebody has answered for you. Answered sure, but I'm waiting for you to finish your question.
Oh, I finished my question.
Oh, so you see questions that I would have thought.
So have you been to Texaco?
Say it again.
Have you been to Texaco?
I'm going to go to Texaco.
Yeah, Texaco, yeah.
Okay, is this another half a question?
No, it's not half a question.
Texaco, the gas station. Is that a trick question, Croswell?
No, sir.
It's because of the first question. I'm very careful in answering your questions, you know, because I don't want to be tied up. Texaco, but if it is a gas station,
yeah, the gas station.
I don't use Texaco gas now.
Why the oil good?
I just never normally trust it. I think Texaco is expensive. So I use Total.
It is expensive.
Yeah, so I use Total. I used to use Rubis, but I kind of move away from Rubis now. So I'm a Total guy now. All right, let's go, because we're catching this in now. Let's go. Number 14, answer.
1/1. Wait. Christ.
All the learning when doing.
0/1.
25/4.
1/0.
Yes, 25/4.
Yes, because the top is
6.
4. The highest is at the top.
So it's going to be what?
6.
Oh, sir, 6/0.
6/0.
So 6/0 is 6?
No.
6.25, sorry.
It's in, no.
Sir, it's mass error. It's an error. Give me, okay, very good. Give me another word for error again. Give me what just when
Indeterminate.
The undefined.
All right. My marks is for now, sir. What's the difference between indeterminate and undefined?
Indeterminate means that it can be solved, but you have to do something else for it. Undefined means that there's nothing more you can do to it.
Oh, okay.
Yeah. So indeterminate means that you
gain the solution, but you can't.
Unsolvable.
Oh.
Unsolvable. Unsolvable. But indeterminate means that if you do a little tweak into the something, it can work. Are you in agreement that this is undefined?
Yes, sir.
Yes, sir.
Who told you that you could see a big question like this and just be able to just twerk it into your head?
Sir, quick math.
Quick math. So the point I'm making is, you're going to your mid-semester for argument's sake, or you're going to your final exam for your argument's sake. You know what you're looking for. You know what you're looking for. So you're looking for 6/0. So when you work your question and you get anything other than 6/0, what are you going to say to yourself?
Sir, I'm gonna say, do it again.
They say wrong. What's the point I'm making? You can't get one limits question of this nature and not get full marks. Crazy. And you already know the answer. You already know what your answer is, so you're working towards the answer. Yeah, man.
Sir, funny thing about that, sir. I didn't realize that there's a power to the fourth, sir. So when I saw the 25 and the 4,
I figured that's the reason you gave me the answer you gave me. So I'm going to use that error that you made earlier to say to you, you must be careful in looking for the term that has the highest power, because it will not necessarily be at the start nor the end, but then itch it up somewhere in between the function. So look at the function to make sure that you're doing your due diligence. Everybody agrees with that answer now that I have on screen?
Yes, sir.
Is there anybody having a difficulty to solving these questions by inspection? There's one thing I'm going to ask, there's a rule that I'm going to ask you to write for me, There's a rule I'm going to ask you to write for me. All right. Let's continue. I think I have more than these questions here. All right, let's go to that one now. So, and I'm coming back to this one. I'm coming back to my rule. So, was it Crosswell? One of you gentlemen asked the question, sir. What if it were negative? And I said, you work it same way, not a difference. What I'm going to say to you, you notice that all my terms here are positive. 6x to the fourth plus 24x cubed. Well, not all of them. Minus 7x.
Yes.
Over 4x cubed plus x to the fourth. But this limit is tending to negative infinity, not positive infinity. Oh, and incidentally, you can have an indeterminate form, negative infinity over negative infinity. Right? You can have an indeterminate form as negative infinity over negative infinity. Just saying. All right. Now watch me. 6x to the fourth. If you're substituting a negative number, because I'm raising it to a positive power, my result is positive. This here, because if I raise a negative number to an odd power, my result is negative. So this would be a positive number minus a number minus another number. This is going to be a negative number plus a positive number. So the truth of the matter is, when you look at the numerator here, positive big number minus a smaller number minus a smaller number, up here says still positive. That's why I have a positive infinity. Down here, so the highest power is x to the fourth. So this number is smaller than this number. But sir, this have a 4, so what? It's a negative infinitely large number put in there. And when you raise this infinitely large number to an odd power, it becomes an infinite, it becomes a negative number. And that negative number plus a positive number. This is a bigger number because it's x to the fourth. So this here is positive. So I'm going to have positive infinity over positive infinity. Positive infinity over positive infinity. Positive infinity over positive infinity. Right? So in a case like this, what do you think your answer is going to be? Look at it and tell me. In a case like that, what will your answer be?
Sir, 6 over 7.
6.
Sir, 6.
6.
Sir, 6.
Jojo, how you get 6 over 7?
Sir, I me keep on I write it wrong. Instead of a plus sign, I have 7x to the 4.
Okay. So your answer is going to be what, Jojo?
Sir, 6.
Okay. Everybody agrees with that?
Yes, sir.
Full agreement. All right.
Yes, sir.
Can I be honest with you?
Maybe. Sure. Go ahead.
Let me scroll on the answer first.
No, sir.
What's the answer?
Sir, 6.
6.
That's what you guessed?
Yes, sir.
Yes, sir. I will guess 6.
Okay. Let me tell you, let me try and be honest with you. My energy for the class has dwindled. It is not up there as I want it to be. Mark you, I know some of you are learning, but I have been a teacher for many years, and I know that there are students in the class that are not following, don't have a clue as to what is happening. When I say don't have a clue, no know what one. And you guys are seated there and not doing anything. It kind of does not feel saddish. Talk to one student, a student come out of class. You never say me have what's already. When it is that all I'm trying to do is to get you guys to recognize that you have a responsibility. I know the students in the class that are understanding, but there are still students in this class right about now. If I ask you to do something you don't know what to do because you still don't understand, and you refuse to say to me, sir, I am not following you. I know it is so unfortunate about it. There are two things that are unfortunate about it. I am in class and people are unmuting and asking me questions, and I'm responding. And when I respond, it benefits everybody. But there are students in the class. When I call upon them, they are muted. You know, so the second thing in that, it shows me how selfish you are because you're not understanding. Then, sir, how me not understanding me selfish? Let me explain. You're not understanding and you're not asking your question so that it can benefit somebody else. This is how you learn, by listening to other questions. You hear what Nikki said to Crosswell a while ago? You can repeat your question for me, please? This is how we learn, by listening to other questions, other people's questions, and formulating questions of our own. Some of them are just selfish beings to yourself and to others. So I just don't feel as energized as I would want to. Mark, you know, if I was a bad teacher, I'd say, all right, come here. Those who follow me, come here. Those who not follow me, you can stay behind. I could do that. But that is not me.
To be fair, sir, I didn't get the method to demand this the first time I saw it because
No, but hold on, Crosswell. No, hold on, Crosswell. You are not the issue. You talking to me in class. No, you are not the problem, Crosswell.
No, that's
so
not
no, what I'm saying, no, hold up. What I'm saying, whether or not you got it the first time, the second time, or the third time, or don't get it none at all. You are one of those vocal ones in class that I can tell you that you are understanding because you are verbalizing stuff to me. The issue that I'm having, and I'm going to speak to Mrs. Campbell about it because it's easier, much easier for Mrs. Campbell to find another lecturer for the course so that you guys can all pass the course than for me to come and sit down and talk to you about you not doing what it is that you're supposed to do and wasting your time. Because when you're not learning, you're wasting my precious time and I am wasting your time. So it is very easy for us to find. We have many lecturers who can teach Calculus 1. I'm not the only one. We have many lecturers. So I'm going to suggest it to her.
Why is I want to do that?
No, because I mean, I don't want to be selfish to teach a class and then only half of the students pass.
Trust me, sir. If we get another teacher, it will just mash up the entire
maybe that's what needs to happen. Anyway, let's go. Maybe that's what needs to happen. Anyway, let's go. Come. What's the answer for that one? Number 16.
Sir, sorry.
4.
Sir, 3/2.
Very nice. Daniel.
Wait on, let me see something.
Jesus, man. Very good.
Yeah, 3/2.
Yeah, that's all I'm asking for. That's all I'm asking for. That's all I'm asking for. Just pay attention and just the work. That was very good. Very good. Very good exercise. So you notice I want to give you maybe two questions. I think I gave, or maybe three, whatever it is. Very few questions on the negative infinity, because they recognize that it is worked in a similar fashion to the ones that are positive. True or false?
True.
True.
Yeah, man. Yeah.
That's one.
Real talk. Real talk. I kid you not. Real talk. Real talk. All right. Very good. Very good, guys. It's 9:41. I may just use about 9 minutes just to talk to you about something, about the limit of a constant. And I want you to forever remember this, that the limit of a constant is the constant itself. The limit of a constant is the constant itself. So what do you mean? If I ask you to find the limit as x tends to 4 of 4, the answer is 4, because 4 is a constant. Yeah. If I say to you the limit as x tends to negative infinity of 3, the answer is
3.
3. The limit of a constant is a constant itself. Very important. I'm building, you know, because I'm building to something else, where it is that all of what we're doing here, so now, you're going to use it. So you have to get it. Real talk. The limit of a constant is a constant itself. The limit of a constant is a constant itself. I don't want to go through that example just yet, because that one is troublesome. A little later on, when I put on a little bit more, when they start eat little dumpling, they get little teeth, I will come back to that one. This is big school mathematics. The limit of a constant is a constant itself. No one you catch that one day, every single time. The limit of a constant is a constant itself. And then now, you see, when you find the limit of a polynomial, all you have to do, and a polynomial is a function that has many terms. Remember, we have mononomials. How many terms have a mononomial?
1.
How many terms are having a binomial?
2.
Right. And how many are having a trinomial?
3.
How many do you think you have in a quaternomial?
More than
4. 4.
So somebody name quaternomial?
Yeah, of course.
They're more than 4.
No, 4. But guess what now? You see, once you reach 3, we're not call it trinomial again. If you want to reach 3, we just say polynomial here, because poly means many. Poly is many. So we're just going to say polynomial. It means that it has many terms. So if you look at this polynomial, how many terms that polynomial has?
It has 1, 2, 3, 4. 4 terms.
Yeah. Who do you think they work when I said, write this quaternomial for me? Hell no. Polynomial. So when you're finding the limit of a polynomial, all you do is to assume the variable is equals to what it's tending to and make that substitution. Good to go. Done. Finito.
Wait, sir, can you scroll back up?
Can you just repeat? Yeah. Can you just repeat what you said about the polynomial?
Polynomial. I'm saying to you that once you get a polynomial, to find the limit of a polynomial.
Scroll up, sir.
Yeah, come in. Once you get the limit of a polynomial, You just substitute the value into it. You assume that the value is equal to what it is, and substitute that value into the polynomial, and that gives you your answer.
That's it, the -1 and then -3 or something.
And yeah, very good. Yeah. You remember the only time we divide, guys, is when you have a what? Say it no? Hello, guys.
Sir, you divide what? Can you repeat?
No, that's why I'm asking to say it, because I know somebody never get it. I'm saying to you.
When you have a denominator?
No, that's not it. Tell me the only time you divide through in finding your limits. When you're doing what? Say finding the limits as it tends to infinity or negative infinity. You notice that when we were doing the question a while ago, it was when we're finding into an infinity, positive infinity or negative infinity, that we divide by the highest power of truth.
Yes, sir.
Otherwise, what we do? Yeah, very good. Wait. Yeah. Let me say it one more time. The only time we divide through by the highest power in the rational function is when you're finding the limit as it tends to infinity, positive infinity, or negative infinity. Otherwise, you substitute.
Oh, me get it right.
Very good. Very good. That's an you must be more attention. Very nice. Very nice. Proud of you, lucky. And that's what it is. I'm not going to go into my past paper questions. I have some questions here and I have some classwork. But I'm not going to go that. I may give you the classwork for homework. I'm going to give you the classwork. Yes, Poppy.
Yes, sir.
So where do you post the homework, sir? Because you always say they're going to give us homework and then.
What's that group, man? So whenever I send the
classwork,
my notes, the class notes.
Okay.
I will put a 1 question or 2 question right there. But I never sent any the last time because boy, don't know when they turn the block on the eye and say, boy, thank you, sir. You know, it's and this is what I'm talking and forgive me, but this is what I'm talking about. There is some basic etiquette that we need to learn in an online medium. I hear some people talk about how we don't like online because online is online. If you don't follow some basic ethical or the experience is not going to be good. So we have what we call netiquette. So when someone is speaking, you give the person that opportunity to speak. You never say, Lord, chat so much. You always ask question, no. That's not nice. So there are some basic netiquette. When the teacher calls upon you, you respond. Because when you ask me a question, I'm not going to respond to you. So if we understand this sort of netiquette, what is going to happen is that we're going to have this sort of symbiotic relationship. You're going to find out that the online experience is as real as the face-to-face experience. And, you teacher, you learn and you understand and you move on and you write any exam you write and you most pass. All right, most pass. Finally, no, let me not ask it that. Let me leave it until next class. No, let me ask. So I gave you 2 types of questions. I gave you 3 types of questions for the infinity, finding the limit as x tends to infinity. 3 types, 3 different sets of examples I gave. Any one person, I want you to name me 1 each and give somebody an opportunity to try and find the other one. So there are three different types. I don't know if you're recognizing, but there are three different types. Three different types. When you are solving those by inspection, what type of answer you expect to get? Describe the limits for me to let me know what type of answers you get. Oh, anybody, somebody.
Sir, is the terminology that you expect us to answer we have used before?
Not necessarily. Put it in your own words. So, okay, let me give you a hint. When do you get 0 for your answer versus when you get undefined versus when you get a real number answer or a fractional answer? A real number. So there are three different types. One, you can get a real number, either 2 or 2/3. In other instances, you can get 0. But yes, in another instance, you can get undefined. I need 3 of you to answer. Anybody take whichever one you want to pick first.
Okay, so we get the undefined when the one with the fraction with the highest power is at the numerator.
Very good. Excellent. Courage. Full stop. Don't say nothing more. Very good. Excellent. You're in class tonight.
I didn't hear.
What she said is that she said that you'll get undefined when the highest power is in the numerator. Very good. It will be undefined when the highest power is in the numerator. All right. When do you get 0? Somebody else, when you get 0.
When the highest point is in the denominator?
Very good, Lati. When the highest power is in the denominator. It's all that I'm going through there, so we can come back a little later on in calculus 2. The same something here. So very good. When do I get a real number?
A real number? When the wait, real number is it, right?
Sir, when both powers are in both spheres, so to speak, I don't know how else to put it.
In the numerator and the denominator.
In the numerator and the denominator, and there are coefficients beside.
Very good. Excellent. Very good. Very good. That's all that it was. I could have come to class and the summary that we just made a while ago, I could have made that summary to you, but I said, no, I'm going to have you discover it. And this is what we call discovery learning. So you say that you know that you discover it. And Crosswell, forgive me, Crosswell, I have a cousin who is Caswell. So every time I see your name, I end up calling your name twice because I call you my cousin's name first. So when you look at the question, you will see exactly what it is. I could have come to class and give you the stuff, and I said, no. Let you come and discover it on your own, because when you discover things on your own, it stays with you. So when Crosswell explained his observation, I felt like I taught tonight, because he verbalized it exactly how I would have verbalized it. And when I said, do you understand? Yes, sir, I agree with Crosswell. It made me feel proud. And that's what teaching and learning is supposed to be. At the end of the class, I can say, what was the takeaway? And you can give me that, you're good to go. You're good to go. Finally, for me, for tonight, just a word of encouragement, guys. When the teacher loses the passion, the teaching and learning process becomes much harder. You have to keep me alive on tippy toes so that I can come across, so that you can feel what I'm feeling, so that you can pass the course. I do not want to come to another class and I call upon anybody. You don't respond to me. Bottom line, downright, are bad manners. none of manners. Somebody I talk to you, to respond, at least respond to the person. And I'm very serious about it. And if it continues, if it happens for the next class, best believe that I'm going to speak to Mrs. Campbell and take myself away from this class. Honestly. Really tough.
And before you leave, just before you leave, you can just repeat the 3 points. No man, the 3 points so I can know.
The 3 points. I know that's what I'm talking about. So point 1, undefined when the highest term is in the numerator.
Sir,
Undefined.
sorry for you. But like we're a good student,
unless I'm gonna have 2 groups. I'll take the ones that will talk and the other ones that won't talk, go to somebody else. The highest power in the numerator, your result is going to be undefined. The highest power in the numerator, your result is undefined. The highest power in the denominator, your result is 0. When you have an equal power in numerator and denominator, you'll get your answer from there. So you get like you may have, the answer will be the coefficients of the terms in the numerator and denominator. So if you have 2x to the 4th over 2x to the 4th, it's going to be the coefficient 2 and 2. And when you simplify it, you can get 1. So the coefficients will formulate your final answer when both the highest power exists in both numerator and denominator. When the highest power exists only in the numerator, your result is going to be undefined. When the highest power exists in the denominator, your answer is going to be equal to 0. And it's very important. Like I just said, that secret, your common coursework piece is written long before we started classes.
So,
long before.
Since you bring that up, sir, will you post them on Edicus out?
Yeah. So one of these nights, we're going to turn on our cameras and we're going to do our mid-semester. But all I'm going to tell you is all of them 3, something there we will go through. And you can do them there. You can do all of what we finish off tonight. You have about 10 or 12 marks already, or maybe 8, anywhere between 8 and 12 marks already on the mid-semester. Because questions like them here, they're on the mid-semester. And I tell you the real something. So if you master this, you know so you're passing the mid-semester. And I will say to you, maximize on the mid-semester so that if when you get further down into the course and you book up on something where you can't manage and you book up in the exam, because you have a high coursework grade, you can at least see your way through the course. You get that? See your way through the course?
Yes, sir, I got it.
Okay, you got it, yeah. Right? So it's very important. And I'm saying to you, what it is that we did tonight, step on the mid-semester. I don't know what question it is, but I know it's on the mid-semester. I don't know what questions come in, because a group of us from the different colleges came together, but we know that this topic is there. All right?
Yes,
have yourselves a wonderful rest of the night.
Thank you, and same to you, sir.
Thanks,
Same to you, sir.
Good night, sir.
Good night, my dearest.
Good night, sir.
Yeah, man. Bless up.
Good night, sir.
Good night, hon. Good night.
Sir, good night.
Good night, Poppy. Good night.